Okay, thank you everybody. I'm Ong from SMT. We are the solution provider for Industrial 4.0, and I want to thank you, the organizer, give me this as opportunity to share our experience related to the Industrial 4.0 transformations and also related to sustainability. First, I would like to share with everybody related to Industrial 4.0 and the standard that is being recognized and used in these transformations. And also later we will have a case study and we also share with you some of the sustainability that we have achieved. Okay, related to Industrial 4.0, for every transformation, they must have a reason why we need to transform. For manufacturer, why you need to do the transformations. So actually, there is a consumer behavior changes related to these manufacturing changes. As we all know that the new young generation, their consumable behavior are more towards characters rather than doing brandings. You know, this is one of the reason and causing the custom manufacturing, and also because of the ease of use of this internet and communication tools. Actually, nowadays customer are easy accessible to communicate with the manufacturer. So a new model of C2M business model is coming up. Uh, Plus, as everybody know, the product life is getting shorter. So a new products being generated in a much shorter times. So this create a need of high mix, low volume manufacturing. And for manufacturer side, as you know that uh, now we have this sustainability, carbon footprint issue, and so on. But beside high mix, low volume manufacturing, for sustainability, also they have to look after three main factors. There is the quality, the cost, and the delivery. So this generate Industrial 4.0. Okay, so for Singapore, we have come out a guidelines course series, and you have 3 building blocks and 16 dimension to give a guide for people who wanted to do transformation. Before you do that, you do a self-assessment. These are a good guide for every company to follow so that you can so-called do a diagnosis of yourself, which are the weak area, bottleneck, so that you can improve yourself. And for Industrial 4.0, actually there are different level of Industrial 4.0 that it depends on your needs that you implement. It's not one standard solutions. Of course, everybody is getting towards digitalization, high mix, low volume, and so on. Okay, but before you do any implementation, standardization is very important. This standardization is not only following what international standard or whatever. It's also a standardization within your own SOP in the factories. Okay, so now when you do Industrial 4.0, when you want to do transformation, you have to choose the right solutions. There's some basic guide for that. Whether you are using only digitalization or digitalization with automation, or you really go into the area of advanced manufacturing. So there is a difference between automation plus digitalizations. This we call it a open loop control. Later there is a slide that show a bit difference between these two. And when you come to advanced manufacturing, you're talking about more into autonomous. You're talking about central control, closed loop control, you know, in real time. This is what is the difference between these two. And so you can see that if it's high mix, low volume, really high mix, low volume, advanced manufacturing with a closed loop control is a much better solution. But if you have a volume batch, and then you can have a choice of both. Okay, because I use this related to precision engineering. In precision engineering, as we all know, one of the pain point is setup. So if you have high mix, low volume, you have a lot of setup. Sometimes, you know, you may spend 1 hour of setup and only 20 minutes of machinings. So these are the pain point of for operating a precision workshops. So you have to look at this thing carefully. And if you are in high volume, most of us will use digitalization and maybe you will use automations because a full automatic line for high volume manufacturing, there is less chance for human to do intervene. They are only doing monitoring and control. Okay, then standardization is very important when you want to implementing this. So there's two areas I want to share with you. For example, that in precision engineering, when you are doing standardizations, you have to standardize your ops SOP and you standardize your so-called communication language, include machines. So normally in precision engineering, we standardize one thing which is the most important. We call it the datum of the factory. You have to ensure that your design datum, your manufacturing datum, your fixture datum, your quality control datum are united into one datum. That is called factory datum. And which equipment is the command of this datum is your quality control. It's not your production machines. Because as we all know in precision engineering, the quality control equipment is the only tools that talking to your customer. So you have to use this as a standard, as a master. So all the machine in the production floor will listen to this quality control equipments. Okay, and you once you united this, you are able to transfer parts from machine to machine seamlessly. In precision engineering, we all know you want to maintain accuracy. Normally, when you put a part onto the machine, you try not to transfer it to another machine. You want to finish all the process in one machine. But actually, once you unite this datum, you are able to do transfer and tap on the advantage of different capability of different machines. Okay, and another standard is the communication protocol. So SSC, Singapore standard, okay, we come out some standard data I will share with you. Now, this slide I will share with you a bit different between digitalization, automation, and advanced manufacturing. If you look at a lot of these solution provided, digitalization, what the planner or we call CAPP is the planning system. They plan a lot of this so-called job sheet, job cut, job order. Whether you are in the old time of paper form or in a new way of using this electronic data transfer, but you are still using this SOP, right? And then the shop floor people will take this and they will start to implement executions. So human are the bridge on these operations. And when you use advanced manufacturing, a bit different in this operation SOP. What we do is the planner will plan all the jobs direct to the machines. And in the shop floor, the machine will receive these orders. When they ever they need help, there will be a communication tools between the shop floor people and the machine. The machine will inform the shop floor people what they need in order to complete the job. In this case, you will know that you will require less manpower in the shop floor. First thing. Second thing is the people in the shop floor don't have to carry a lot of job sheet, job cut, or remember a lot of procedures. They just follow and fulfill the need of the machine in order to finish a job. So advanced manufacturing is a closed loop. Okay. And then the digitalization with automation is the open loop. This is a difference between these two systems for high mix, low volume manufacturing. So advanced manufacturing now, there's a lot of technology we already developed till after you do the planning, even the planning to the production floor is auto. You don't have to get somebody to do the production planning. And from there, then you can have auto planning APS. Then you can have a MES to do the advanced manufacturing execution according to the instructions between automation system and the machines. And you have a in-process quality control that do automatically, and you have an auto error correction. What is this? This means that when the part is making halfway, let's say it's a WIP, work in progress, you can bring this part to the quality control equipment to do a testing or a measuring, And if you find an error, this system, quality control system, will able to communicate to the production machine to do auto error correction by itself. So you don't have to have humans there to do these actions. In the past, we always have a QC department, we have a production department to do all these things, and the machine have to stop for a decision make. So this is all a wasting of resources. Okay, so this is part of advanced manufacturing. Now, come to standard. Thanks to SSC Singapore, we recommend some standard being used in this industrial 4.0 advanced manufacturing transformations. Here are some of the standard that we use. We already identified them, and you can later take a look at this thing, and you can go to the web and you can trace what is all this all about. I will use one of the example is OPCUA. OPCUA is one of the popular standard is being used now. So what is OPCUA? Now, in the past, when we do digitalization, we only need data transformation, MT connect or whatever, or you have a IoT with a gate and you only transfer data. But now go into advanced manufacturing, you require command and control in real time. So command control must have a standard. So the advantage of having this standard, this means that you will help a lot of future developer that you can able to use this standard to develop their new tools, and you can control a lot of equipments without going to individual equipments to ask for the library. Okay, now this is OPCUA, the protocol. Okay, but this require a lot of effort from the controller or the IoT manufacturer. They need to have this OPCUA, we call it the API, in order to for other developer to use their equipment seamlessly. Okay, so this is one of the standard that we use. And here are two examples that we use this OPCUA. Okay, this is the model factory in Simtech. And this is one of the solution when we apply within the equipment itself, because we are using edge computing method. Within the equipment itself, we are using OPCUA. But when you do the communication to the central control, we are using TCP/IP. We do, because we required, you imagine a factory, you have hundreds of machines. So sometimes you don't want to jam up the bus communication. So you have to use certain other way. It depends on the situations. But there is a standard for you to do this. Okay, so these are the case study of a transformation. It also related to help in sustainability. For example, in the past, you use a lot of paper planning, you do a lot of this kind of communication, human communication, face to face or whatever. But once you go into digitalization, you have less human traffic moving from division to divisions, right? And you use less paper because you do direct communications. Okay, this will help in a lot of energy saving in maintaining the environment, especially in precision engineering. And this is a transformation also that what it helps is really the efficiency is growing 300 over %. This means that you less machine, less human inside the factory, you are able to produce even more. This is also saving the energy. And the advantage of over this thing is because it's autonomous. So in precision engineering, if at the night time, if you are not using the equipment for production, you still have to maintain the environment. So aircon, energy, all those are really very substantial. But if you autonomous, you are able to do production even 24 hours to make use of all this. And data, we also develop our new system that what we do is related to sustainability. Our MES and monitoring system will work with IoT. We will do real-time traceability of energy used to produce a part, or trace machine energy used for a lay versus the output. And we are working computing to further enhance this into carbon footprint calculation and reports. So these are all the areas that in sustainability that we have improved. Okay. So inspiration. Then to save we call resources. We all know that SME especially in precision engineering, you wouldn't have a full capacity running in the factory. So why not you go into cloud manufacturing like Uber's? You share your resources and manufacture, share your capability and resources, and you can manufacture together. Under this platform, the machine will able to communicate between factory to factory and join the manufacture to produce things. So you can tap the resources, we can share the resources. Okay. So by this, I end my presentation. 15 minutes. Thanks.